In this problem, we're going to sketch the graph of a sine function by plotting points. We want to graph y equals 2 and sine of x over 3 minus pi over 6 by hand. We're going to start by comparing this to y equals a sine of omega x minus phi. We see that a is equal to 2, omega is equal to 1/3, and phi is equal to pi over 6. So the graph is a sine curve with amplitude, absolute value of a, which is the absolute value of 2, which is equal to 2. We'll have a period of 2 pi divided by omega, so 2 pi divided by 1/3, which is 6 pi. Then we'll get a phase shift of phi over omega, so pi over 6 divided by 1/3, which is equal to pi over 2. So we've got an amplitude of 2, a period of 6 pi, and a phase shift of pi over 2. Go ahead and look at a graph. We know that the graph of our function will lie between -2 and 2 because we had an amplitude of 2. One period will begin at x equal to phi over omega, which is pi over 2, and it will end at x equal to 2 pi over omega plus phi over omega, which is 13 pi over 2. So we're going to look at one period over the interval pi over 2 to 13 pi over 2. We're going to divide that interval up into 4 sub-intervals that each have length 3 pi over 2. So we'll start at pi over 2. Each of these tick marks represents pi, so each intermittent mark will be pi over 2. So we'll start here at pi over 2. Each of the sub-intervals will have length 3 pi over 2. So we'll mark off 2 pi, 2, 3 pi over 2 is 1, 2, 3 pi over 2, and one more, 1, 2, 3 pi over 2. So here we have 13 pi over 2, started at pi over 2. We'll have 5 key points for our graph. The first point is our initial point, pi over 2, 0. So we started our period at pi over 2. The next point will be at 2 pi. This is where we'll reach our maximum value. So we have the point 2 pi, 2. We'll again hit the x-axis at the point 7 pi over 2. So we have 7 pi over 2, 0. Our next point will be at 5 pi. And here we'll hit our minimum value of -2. So we have the point 5 pi, -2. Then we'll get our last point at the end of one period. This will be the point 13 pi over 2, 0. If we connect these 5 key points with a smooth curve, that would give us the graph of our sine function over one period. Then we could extend that graph in both directions to get a more general picture. If we do that, the graph of our sine function will look something like this. Notice we have our 5 key points, pi over 2, 0, 2 pi, 2, 7 pi over 2, 0, 5 pi, -2, and then lastly 13 pi over 2, 0. So we have one period between pi over 2 and 13 pi over 2, and we have extended our graph in both directions to show that it continues on in the positive and negative x direction.